ఊడిపోయింది. గుడ్ ఈవినింగ్ రా. మా ఆన్లైన్ స్టూడెంట్స్ ఎంతమంది ఉన్నారు ఒకసారి ఒక్క నిమిషం. మీరు ఎవరైనా ఫోన్ తెచ్చారా? చూడు, లింక్ ఏమైనా వచ్చిందా? నువ్వు ఫోన్ తేలేదా? అరే ఈ ఫోన్ తీసుకురారా. చూడది యూట్యూబ్లో పెట్టుంటారు లింక్.
యూట్యూబ్
అది ఆల్రెడీ గ్రూప్లో లింక్. యాప్లో కాదు, అది గ్రూప్లో పెట్టుంటారు లింక్. దీని లైట్ ఇంతేనా? సిగ్నల్ లేదరా? ఓకే అమ్మా, గుడ్ ఈవినింగ్ రా. Okay. Let's see. చూడాలి స్టార్టింగ్. Let's see the next one. So today we are going to start with general basics, which are very essential and very useful. Okay. General basics of chemistry, Nana. Today we are going to discuss, which are very useful to physical chemistry. Okay. Okay, see. So, if you need to learn, we have actually 3 parts of chemistry. Okay. The part 1 is general chemistry, which is including with inorganic part, inorganic chemistry. The part 2 is organic chemistry. While coming for the part 3 is physical chemistry. Part 3 is physical chemistry. Physical chemistry. So if you need to learn physical chemistry properly and do the problems in an easy way, okay, okay. Now, physical chemistry how to handle with simple logics, okay. Right, see how to learn the physical chemistry in a shortcut way. Actually, the physical chemistry is associated with many different problems with very, very small basics. So that is the reason we are going to learn the basics of physical chemistry. Okay, we are going to start with physical chemistry basics. Basics of physical chemistry. So what are these essential basics? If you need to solve the questions in physical chemistry, definitely we needed somewhat basic concepts. Somewhat basic concepts we needed. So what kind of basics we need to learn? You can see these are the basics which you are going to learn from these concepts, that is stoichiometry. Stoichiometry. Okay. In stoichiometry and general basics of chemistry, we are going to learn some of the very, very simple problems. So what are those? Those are based on mole concept. Remember, based on mole concept we can learn. This is very, very important concept. And besides this, we have some other important topics like oxidation numbers. If we have the oxidation numbers, then we are going to balance the equations, that is called balancing equations. Balancing equations. Okay. And besides this, we have stoichiometric calculations. Stoichiometric calculations. Very, very important parts these are. If you don't have these particular data related this particular concept, it is quite difficult to solve the questions. So that is the reason we need to go with these particular concepts like mole concept, oxidation number, balancing equations, stoichiometric calculations. So students, today we are going to start with mole concept. In mole concept we have different contents. That contents we are going to learn today. Okay. See Nana, what is mole concept and what are the terms we have? Mole concept. Mole concept. What is mole concept? What are the important terms we have to learn? Mole concept. See properly. In mole concept we have things like this. What is that? Stoichiometry means we need to measure the elements. We need to measure the elements. Because if you need to describe any substance, we have two basic analysis we have. One is called qualitative analysis and the other one is quantitative analysis. Qualitative analysis and quantitative analysis. Quantitative analysis. For example, you have a substance. That substance can be with which it is made up of. That is called composition. If you need to find a composition of any chemical substance, for that we can use qualitative analysis. Like salt analysis, which you are going to do in your 12th examinations as you have practical skills, like practicals. There you have some of the questions like what are the cations and anions are present in a given salt. They are going to give like that. So if you need to describe the cation and anion analysis, we are going to do certain experiments or certain tests we are going to do. Based on the tests, we are going to find what kind of cation and what kind of anion we have in the compound. That is called qualitative analysis. The qualitative analysis is completely brings the relative data of composition. The relative data of composition. That is the first thing. Coming for the quantitative analysis means the amount of or the exact quantity, the amount of substance present in a given component, the amount of substance present in a given component. The substance present in a given component is called quantitative analysis. Means we are going to find what is the exact quantity present in a given substance. That is actually quantitative analysis. Okay. Now see. Now see. So coming for the mole concept, the quantitative analysis, from this we are going to find mole concept. In mole concept, what kind of things we are going to find now? This is the we have. First we are going to start with the word. What is the word we have? Unified or atomic mass unit. Subheading unified or atomic mass unit. Unified or atomic mass unit. Sir, what is unified or what is atomic mass unit? The atomic mass unit or unified is the units to express the masses of the mass of atoms or molecules. Okay. What is atomic mass unit or unified? The unified is nothing but it is one kind of unit to express the mass of atoms or molecules. Atoms or molecules. For example, if you need to express the quantity of a given bulky substance. For example, I need to purchase sugar. Sugar need purchase cheyali to go to the market. How do I ask? Give me 1 kilogram of sugar or give me half kilogram of sugar. We can ask like that. In the same way, if you need to describe the mass of a given atom or molecule that is very, very tiny particle, to express the mass of that tiny particles, we can use a special units called unifieds or atomic mass units. Unifieds are atomic mass units. So what is unified or atomic mass unit? What is unified or atomic mass unit? So how do we define the unified or atomic mass unit? This is, for example, let me concentrate. This is as carbon 12 isotope. What we have? Carbon 12 isotope or carbon 12 atom isotope, because carbon has different isotopes. Carbon 12 we have, carbon 13 we have, carbon 14. So what is isotope? The same atom of element available in different mass numbers. That is called isotope. Okay. So among all the isotopes, the carbon 12 is the isotope which can available with more percentage, means most abundant element. So that is the reason we are taking carbon 12 as reference to express the atomic masses of entire atoms. Once again I am repeating, the carbon 12 is the most abundant element on the universe, especially on this earth. So that is the reason we are taking carbon 12 as our reference atom, as our reference atom. Now see. Example. So coming for that, if I am taking C12 isotope, let me make this into 12 parts. Let me make this into exactly 12 parts. 1, 2, 3, exactly 12 parts. Now among these 12 parts, if I am going to label one of these 12 parts, now this is called unified. What is this? Unified. Okay, Rana? What is unified? Unified is nothing but what is unified? Unified equal to 1/12 mass of carbon 12 atom. Carbon 12 atom. Unified equal to 1/12 mass of carbon 12 atom. Carbon 12 atom. So now, what is the mass of carbon 12 atom? 1.9926 into 10 power minus 23 grams. So how much part we need to take? Exactly 1/12 part. So you can write. See, Nana? 1/12 part means unified equal to 1 unified equal to the mass of carbon atom 1.9926 into 10 power minus 23 grams. Let me make this into exactly 12 parts. Exactly 12 parts. If you take one of the 12 parts of the carbon 12 mass, that is called unified. So the mass of each carbon 12 atom is 1.9926 into 10 power minus 23 grams. But unified means exactly we need to take 12th of the mass of 1/12 of the mass of carbon 12 atom. So that we can write 1 unified equal to 1 unified equal to, that is 1.9926 means you can get 1.667 into 10 power minus 24 grams, because minus 23 turns into the minus 24. Okay. Minus 24 grams, 1.667 into 10 power minus 24 grams. As we discussed already, these are the units to express. These are the units to express atomic mass or molecular mass. You can see some examples. Example, the atomic mass of hydrogen if we have, that is 1 unified. The atomic mass of nitrogen, that is you can write 14 unified. The atomic mass of, the molecular mass of nitrogen is 28 unified. That means the atomic masses and molecular masses. This is atomic mass, molecular mass. That indicates that contains only one atom of hydrogen. That indicates one atom of nitrogen. This indicates one molecule of nitrogen. That indicates only one particle. The each particle weight or each particle mass can be expressed with the help of unifieds or AMU, atomic mass unit. Right. Okay. Next one. Next one. And coming for the other terms, atomic mass, we are going to express in unifieds. And coming for the relative atomic mass or relative molecular mass. Relative atomic mass or relative molecular mass. Sir, how do we find, before that and one more concept, how we are going to find the atomic mass? How we are going to find the atomic mass? How do we calculate? The atomic mass of any element is going to be expressed in terms of average atomic mass. ఏ టర్మ్స్లో ఎక్స్ప్రెస్ చేసుకోవాలి? యావరేజ్ అటామిక్ మాస్. ఓకే, ద అటామిక్ మాస్ we are going to express with respect to average atomic mass. Average atomic mass. Sir, what is this average atomic mass? What is the meaning of average atomic mass? The simple thing, for example, I have chlorine. The chlorine can available in the form of isotope 37 and 35. For example, if you think so, chlorine is available in the form of chlorine 37 and chlorine 35 mass numbers. On the earth, it is available in the percentage of X percentage and Y percentage. If you think so, this is nothing but percentage of abundance. What can we say? Percentage of abundance. If one element is available in different isotopes with different percentage of abundance, in such a case we are going to find the average atomic weight by using this formula. So that means the average atomic weight equal to formula 37 into X by X plus 35 into Y whole by X plus Y. This is the average atomic weight. Average atomic weight. In such a way, we are going to find the average atomic weight. So, what is the atomic weight of fluorine? We are writing chlorine 35.5 unifieds we are writing. This is nothing but the average atomic weight. Okay. Next one. Write down one question. Example. The boron is available in two different isotopes, that is boron 11 80% and boron 10 20%. Then the atomic mass of boron is question mark. Can you solve this? Do it fast. As I gave already, if you have the percentage, Amma or see, online students, you also do it. It is very, very easy question. Amma, if you are getting any answer, just you can express your answer through live chat. Students, Abhi, Chitti, Ramakrishna, SSV, Amita, Teja, Venkatesh, Sarika, Honey, Chitti, everyone, Nana, Vamsi, Sridevi, everyone, please respond your answer with through the chat. 10.8, yes, 10.8 is the correct answer. 10.8 is the correct answer. Yeah, Srinu, very good, Nana. Srinu, very good. Okay. So as we discussed already, what is that? The average atomic weight equal to the sigma percentage of abundance. Otherwise, you can write directly formula. The atomic weight formula what we gave? 11, the percentage is 80 plus 10 into 20 whole by 80 plus 20. This is 11 8 is 880 plus 200 whole by 100. That you can get 10800 by 100. This will cancel. Sorry, 1080 you can get 1080 you can get by 100. This you can get 10.8. 10.8. Write down now. Okay, na? Right, see the next one. So first concept is over. The next one, relative atomic mass or relative molecular mass. Relative atomic mass or relative molecular mass. Sir, what is this relative atomic mass or relative molecular mass? How do we define? Now, if you have an atom or molecule, we have an atom or molecule. Now I need to find whether the atom of element is heavier than 1/12th mass of a given carbon 12 isotope. That is nothing but unified. That is nothing but unified. So, how many times an atom or a molecule heavier than carbon 12, that is 1 by 12th mass of carbon 12 atom, that indicates relative atomic mass for atoms, relative molecular mass for molecules. Just we are comparing the mass of a given atom or molecule with the unified. So, relative atomic masses or relative molecular masses are generally numbers. There are no units. We are taking how many times heavier or how many times lighter, that indicates that is a number, right? So, relative atomic mass or relative molecular mass are the number which are going to find how many times a given atom mass is heavier than one unified. Or unified is nothing but 1 by 12th mass of carbon 12 atom. So, based on that we are going to find. So, what is relative atomic mass or relative molecular mass? The number denotes what, Nana? The number denotes the mass of atom or molecule. How many times heavier than carbon 12 isotope. Heavier than carbon 12 isotope. Okay. Yeah, Chintu Raula. Hi, Ra. Chintu Raula, hi. Yeah, how many times you are going to message the same thing? Hi. Chintu. Right. So, how do we write the relative atomic mass or relative molecular mass? Relative atomic mass or relative molecular mass, the formula, the mass of atom or molecule by unified is nothing but 1 by 12th mass of carbon 12 atom. Write down now. Okay, next one. Gram atom or gram atom or gram atomic weight or gram atomic mass. All these three words are same. Okay, now gram atom is also identical with gram atomic mass or gram atomic weight. All these three words have the same meaning. Gram atom or gram atomic mass or gram atomic weight. Chonama, what is gram atom? Yeah, sure, Roja, I am giving each one example, don't be confused. Okay. We are going to discuss with examples only. So see, first listen the concept. Roja. Right, see now. Gram atom or gram atomic mass or gram atomic weight. How do we say? So what is a gram atom or what is gram atomic weight or what is gram atomic mass? If we have the sample of atoms, the sample contains exactly 1 mole. The sample contains exactly 1. Then the mass is called gram atomic mass. What is that? Gram atomic mass. As we learned already, the atomic mass is expressed in unifieds or the molecular mass is expressed in unifieds. Instead of unifieds, if you are going to express in terms of grams, that is called gram atom or gram atomic mass or gram atomic weight. Gram atomic mass or gram atomic weight. So how do we define? What we are doing? Atomic mass expressed in what, Nana? Atomic mass expressed in grams. Expressed in grams. That is atomic mass or gram atomic mass. Otherwise we are going to express like this. That is the quantity of substance is equal to 1 mole of the substance, 1 mole of the atoms. That is also called gram atom. Difference చూసుకోండి. The difference between the unified and gram atom. The unified indicates that contains only 1 atom, while we have the gram atom means the sample contains exactly 1 mole. అంత difference ఉంది. అర్థమైందా? Right. Examples we are going to discuss. One moment, wait a moment, Nana. Online students, be online. Make this complete sentence. Okay? See. So see that the gram atom or gram atomic mass or gram atomic weight is nothing but the atomic weight or the atomic mass expressed in grams that equal to the quantity of substance is exactly equal to 1 mole of the atoms. For example, you can take atomic mass of hydrogen atom if we have. What is the atomic mass of hydrogen? Exactly 1 unified. 1 unified means how many atoms are there? Exactly 1 atom we have. But if you say the same atomic mass, if you say gram atom of hydrogen, if we have, that indicates what is that? That is exactly 1 gram, means 1 mole of hydrogen atoms. That much difference is there. 1 mole means 6.023 into 10 power 23 hydrogen atoms. That is exactly Avogadro number. That much of difference is there. అంటే నువ్వు ఒక మాస్ని యూనిఫైడ్స్లో ఎక్స్ప్రెస్ చేస్తే దాని అర్థం ఒకటిరా, అదే గ్రామ్స్లో ఎక్స్ప్రెస్ చేస్తే దాని అర్థం ఒకటి. యూనిఫైడ్స్ ఇండికేట్స్ దట్ ఓన్లీ 1 particle, means 1 atom. But if you express the same number in grams, that indicates 1 mole. 1 mole ఉందని అర్థం. అర్థమవుతుందా? 1 particle is different from 1 mole of particles. 1 mole of particles means Avogadro number 6.023 into 10 power 23. Right. Okay, now see one more example. For example, atomic mass of oxygen, if I give atomic mass of oxygen. What is the atomic mass of oxygen? 16. Tell me the units. 16 unifieds. Means how many atoms are there? Only 1 atom of oxygen we have. Only 1 atom of oxygen we have. Whereas in the case of atomic mass of, you are going to express it in unifieds. The same word you can express it exactly 1 gram atom of oxygen indicates that 16 grams. Means how many moles we have? 1 mole of oxygen. 1 mole of oxygen. 1 mole of oxygen. One mole of oxygen. Means how many oxygen atoms are there? 6.023 into 10 power 23 oxygen atoms. Okay, na? Right. See the next one. In the same way, molecular mass and gram molecular mass. We are going to find first molecular mass. Sir, what is molecular mass? The mass of a given molecule. The mass of a given molecule. Okay, the mass of a given molecule. Given molecule is said to be mass of molecule. Kamra. Mass of given molecule. Mass of given molecule is said to be molecular mass. Sir, how many types of molecules we have generally? How many types of molecules we have? Some of the molecules are elemental molecules and some of the molecules are compounds. So what is the difference between elemental molecule and compound? Okay, elemental molecule and compound. Okay, elemental molecule and compound. Elemental molecule means the combination of same atom of elements. Same atom of elements. The compounds means the combination of two or more different atom of elements. Different atoms of elements. That is a compound molecule, and elemental molecule means same atom. Okay. Now see, what are the examples of elements? What are the examples of elements we have? Like H2, N2, O2, P4, S8. These are the examples of elements. Whereas compounds examples are combinations, as we discussed already. The combination means like H2O, N2O, NH3, H2SO4. These are all compoundal molecules. Okay, Nana? Write down. Okay. Now see. Now see. How do we find the molecular mass of elements? For elements, molecular mass is equal to atomic mass into atomicity. What is the word I am using? Atomicity. Sir, what is atomicity? Atomicity is nothing but the number of atoms present in a molecule. Number of atoms in a molecule. That is nothing but atomicity. For example, I need to find the molecular mass of O3. The molecular mass of O3. How do I write molecular mass equal to oxygen atomic mass 16 unifieds, atomicity is 3. That is 16 and 3 is 48 unifieds. That is molecular mass. Okay, Nana? Write down. Okay now? Right, see the next one. Next one. O3 is on. Can you find the molecular mass of P4? Do this. Roja, can you do this? Molecular mass of P4. 60. What is the atomic mass of phosphorus? That is atomic number. Jayant Kartikeya, can you do that? Roja, can you do that? Chintu, Srinu, Krishna Sai, Sridevi, Praneeth. Chesarama, phosphorus atomic mass, Antara, 31, right? Unifieds. The phosphorus atomic mass, 31 unifieds. So molecular mass is how much we have? 31 unifieds into 4 you can say, because atomicity 4. So 124 unifieds, 124 unified. Okay, 124 unified. Next, for compounds, how do we find? For compounds, how do we find? How do we find for the compounds? The simple thing, the molecular mass equal to sum of atomic masses. Sum of atomic masses of all the elements present in a compound. That is the formula for molecular mass. Sum means we need to add. Okay. Okay, Nana? Example. We have calcium carbonate. How do we do this? The mass of calcium plus carbon plus 3 into atomic mass of oxygen. So what is the atomic mass of calcium? 40 unifieds. For carbon 12, for oxygen 16. If you add all these together, you can get 100 unifieds. Write down. Okay, Nana? Can you solve for this? The molecular mass of sulfuric acid. Can you solve this? Online students, Jayant, Sunny, Yashasri, Anil, Guru Prasad. చేయండి ఎంత వచ్చింది 98 యూనిఫైడ్స్ అరే చెప్పాలా ఖచ్చితంగా ఓకేనా సో మాలిక్యులర్ మాస్ ఈక్వల్ టు 2 into hydrogens plus 1 sulfur atom plus 4 into oxygen atoms, that is 2 into 1 plus 32 plus 4 into 16, that equal to total 98 unifieds. That is molecular mass. The next one, gram molecular mass or gram molecular weight or gram molecule. Gram molecule, molecular mass or gram molecular weight or gram molecule. Gram molecule. How do you define gram molecule or gram molecular mass or gram molecular weight? As we discussed already. The molecular mass can be expressed in, yes, the molecular mass expressed in grams. The difference between molecular mass and gram molecular mass expressed in grams. The molecular mass means contains only one molecule, but gram molecular mass means contains 1 mole. Okay, that means the amount of substance contains exactly how many molecules? Contains 1 mole of molecules. Means 1 gram molecule equal to, what it indicates? Molecule equal to molecular mass in grams equal to 1 mole of molecules. Write down, Nana. I will give examples later. Write down. Okay na? Right. See example ra. Molecular mass of oxygen means 32 unifieds. The same means 32 unifieds means how many molecules we have? One molecule of O2. How many oxygen we have? 2 atoms of oxygens. 2 atoms of oxygens. Two atoms of oxygens, whereas 1 molecule of O2, that indicates. Whereas 1 gram molecule of O2 indicates that exactly 32 grams. That means 1 mole of oxygen molecules. 1 mole of oxygen molecules, that equal to 6.023 into 10 power 23 O2 molecules, that equal to 2 into 6.023 into 10 power 23. What is that? Oxygen atoms. That much of difference is there, while you are expressed in grams and unifieds. Right. Next one. Next one. 1 mole. What is mole? What is mole, Nana? What is mole? 1 mole means? Remember? 1 mole means if I am taking the quantity of substance or amount of substance. Example, we are going to take a sample of substance or amount of substance that contains the amount of substance contains certain number of particles. How many number of particles that must have when we are going to concentrate as 1 mole? The same number of particles as number of carbon atoms present in 12 grams of carbon 12 isotope. For example, X is one substance. When do we call the X is 1 mole? The same thing, the X atoms or X particles should be there, the same number as the number of carbon 12 atoms present in the carbon 12 atom. Then that X is going to consider as 1 mole. Okay. So how do we define 1 mole? Mole is nothing but the number of particles, the number of particles that is equal to as the number of atoms present in 12 grams of carbon 12 isotope. That is called 1 mole. What is that? 1 mole. Okay. Means how do I write 1 mole equal to how many grams of carbon 12 I am taking? Exactly 12 grams. How much weight of each carbon 12 atom? 1.9926 into 10 power minus 23 grams. So if you simplify, you can get 6.023 into 10 power 23, which is called Avogadro number. దాన్ని ఏమంటాం? Avogadro number. That is Avogadro number. Avogadro number. Okay na? Next subheading na calculations based on mole concept. Calculations based on mole concept. ఈ క్యాలిక్యులేషన్స్ చేయాలంటే if we need to solve these problems, we need to familiar with somewhat words. As we discussed already, 1 mole means what is that? Gram atomic weight or gram molecular weight, right? Equal to nothing but 6.023 into 10 power 23. That is nothing but, that can occupy 22.4 liters of volume at STP or NTP conditions. STP or NTP conditions. Based on this small point, we are going to find the relations. We are going to find the relations. How the problems are there, I will give later. Please note it down, Nana. These are very, very important relations. If you don't have this data, we cannot do any problem. Okay na? Do these problems. I will give some questions. Note it down. You questions cheyandi nana. The number of oxygen atoms present in 0.25 moles of calcium phosphate. Are ye problem cheyalanna, you need to write the molecular formula of a given compound. If you need to solve any problem, you need to write molecular formula of the compound. Do it. What is the molecular formula of calcium phosphate? Can you say what is the molecular formula of calcium phosphate? Ca3PO4 twice. Then do the problem. Online students, you also Nana. Ramakrishna, Sunny, Kartikeya, Anil Kumar, Yashasri, Akhil, Guru Prasad, Solve this problem. Roja, Chintu Bantu, Sridevi, Praneeth, Jitendra, Ramakrishna, everyone. Solve the problem. చేయండి రా, నేను వస్తుంది ఓకేనా. అరే డూ ఇట్ నాన్న, ఐ విల్ కమ్ బ్యాక్. ఓకేనా. Then, did you get the answer? Online students, did you get the answer? Please respond. So see, how do we do this? అరే దీని అన్లాక్ తిరగలరా ప్యాటర్న్ ఏదో పెట్టుంటారు వాళ్ళని అడుగురా ఒకసారి పాస్వర్డ్ రా అదే అడుగురా ఒకసారి అడిగిరా అక్కడ ఉంటుంది కదా మేడం 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 Right. So how do we solve this problem? See now. We have Ca3PO4 twice, right? Calcium phosphate. This is exactly 1 mole. If you write any molecular formula of any compound, that indicates 1 mole of the substance. The 1 mole of calcium carbonate, calcium phosphate contains how many moles of oxygen atoms? 2 4s are 8 oxygen atoms, right? So you can write 1 mole of calcium phosphate contains how many moles of oxygen atoms, Nana? 8 moles of oxygen atoms. 8 moles of oxygen atoms. But how many moles is given that? 0.25 moles of calcium phosphate given. This value we don't know. So simply X. Now cross multiply. X equal to 8 by 0.25, I am writing 8 by 8 into 0.25 I am writing as in the 8 into 1 by 4, because 0.25 is nothing but 1 by 4. 8 into 1 by 4 means we have 2 moles of oxygen atoms. 1 mole contains how many oxygen atoms? 6.023 into 10 power 23. So that you can write 6 into 10 power 23 directly. So 6 into 2 into 10 power 23, that you can write 12 into 10 power 23 oxygen atoms. Very good, Rakil. You are just trying. Sunny, you are also trying. Good. See? So 2 moles means 2 into 6 into 10 power 23. That equal to 12 into 10 power 23. You can write 1.2 into 10 power 24 oxygen atoms. Oxygen atoms. Oxygen atoms. Okay, Nana? You got it? Right. Write down next, one more question. One more question. The amount means weight. The amount in grams of 4.48 liters of CO2 at STP is. They are going to ask like this. 4.48 liters of CO2 at STP is. As we discussed already, at STP 1 mole of CO2 can occupy how much volume? 22.4 liters. So based on that you can solve that question easily. Online students, you also Nana, Sunny, Akhil, Ramakrishna, Jayant. Amma, first coming for that, you need to find what is that? 22.4 liters is nothing but 1 mole. 1 mole of CO2 is nothing but how many grams? Carbon atomic mass 12, oxygen atomic mass 16. 16 to the 32 plus 12, 44. So you can write 44 grams. So we are comparing the volume with weight, right? So you can write directly 22.4 liters is 44 grams. But the given volume is how many liters? 4.48 liters. This value we don't know. So XA, so on cross multiplying 4.48 into 44 by 22.4. This is 1 ja, this is 0.2. So this is 8.8 grams. In such a way we are going to find the calculation. Okay, Nana? My online students, are you clear with this? అర్థమైంది ఎలా చేయాలో దాన్ని కంపేర్ చేయడమే. ఓకేనా? Right. Next one. Next one. See. Next one. See the next one. See, do this question. The number of atoms required required to give 1.12 liters of ammonia gas at NTP. The number of atoms required to give 1.12 liters of ammonia gas at NTP. Do it. You can do this, Nana, Sunny, Anil. మా ఆన్లైన్ స్టూడెంట్స్ చెప్పండి రా, ఆన్సర్ ఏమొచ్చింది? 2.24 liters means 1 mole. అంతే కదా? 1 mole of ammonia contains how many atoms? How many moles of atoms? ఎన్ని atoms ఉన్నాయి? 1 mole of ammonia contains how many moles of atoms? Ammonia NH3 కదా. చూడండి, 1 mole of ammonia ఎన్ని ఉన్నాయి? నైట్రోజన్ ఈజ్ 1 atom, 3 hydrogens. అంటే ఎన్ని మొత్తం? 4 moles of atoms. అంతేనా? 8 point. చూద్దాం, చూడు. 1 mole of ammonia contains 4 moles of atoms. 1 mole can occupy how much volume? 2.24 liters. Can have 4 moles of atoms, means 4 into 6 into 10 power 23 atoms. But the given volume how much, Nana? 22.4 we have actually. 22.4 liters can have 4 into 6 into 10 power 23 atoms. But the given volume is 1.12 liters. This value we don't know. So XA, so on cross multiplying, 1.12 into 4 into 6 into 10 power 23 by 22.4. This is 1 ja, this is 20 ja. 6 4 ja 24, 2 1 ja 2, 2 2 ja 4. 2 6 ja 12 means 1.2 into 10 power 23 atoms. Just needed to bring 1.212 liters. Are you clear with this? Nana, Akhil, Jayant, Sunny, are you clear with this? Ramakrishna? Right down. Okay na? Right, next one. Next question. Next concept, జాగ్రత్త చూడండి. Next concept, stoichiometric calculations. What is that? Stoichiometric calculations. Okay. Stoichiometric calculations. Are up to 8:30 Nana, we have the timings. 6:30 to 8:30. Akhil, we have the timings. 6:30 to 8:30. Stoichiometric calculations, you can remember, if you are going to write the molecular formula or symbol of any element, molecular formula of a molecule or symbol of any element, that indicates 1 mole. What is that? That indicates 1 mole. That is the first thing. The molecular formula of compound or symbol of element represents what is that? Represents 1 mole of that substance. 1 mole of that substance. Okay now? 1 mole of that substance. Okay. Let's see example. If I am writing H2O, this indicates what? 1 mole of that substance. 1 mole. If I am writing N2, that indicates 1 mole only. Right, Nana? This is the first point. If you write H symbol, this is also represents 1 mole. Okay, this is first thing. Second point, the stoichiometric coefficients. The stoichiometric coefficients represents number of moles of that substance. Number of moles of that substance. Remember, the stoichiometric coefficients of a given substance represents the number of moles of that substance. Okay, Nana? See, example. If I am stoichiometric coefficient means whatever the number we are going to write before the molecular formula. For example, I am writing 2H2O. How many moles of H2O we have? 2 moles. How many moles of H2O we have? 2 moles of H2O. Okay, Nana? If I am writing X moles of H2SO4, how many moles of H2SO4 we have? X moles of H2SO4. X moles of H2SO4. If I have some KHNO3 I wrote, how many moles of HNO3 we have? K moles of HNO3. Okay, the stoichiometric coefficients represents that exactly number of moles. నువ్వు ఏది రాస్తే అది ఇండికేట్ చేస్తుంది. ఓకేనా? నెక్స్ట్ వన్. Next one. The formula weight. The formula weight of substance in grams denotes 1 mole of that substance. 1 mole of the substance. The formula weight of a given substance in grams denotes that 1 mole of that substance, remember. Okay. Example you can see. You can see example. Example. H2O we have. ఇలా రాసామనుకోండి. This indicates what is that? 18 grams. That indicates 18 grams. If I am writing H2SO4, that indicates 98 grams. If I am writing H2, that indicates 2 grams. If I am writing N, that indicates 14 grams. Okay. Okay, na? We are finding based on the relative data number of moles. Based on the relative data we are finding number, that is gram molecular weight, means the amount we are finding. Besides this amount, we are also going to find number of atoms as well as volume. Write down next point. 1 mole of substance contains how many particles? How many particles, Nana? 1 mole of substance contains how many particles? Avogadro number 6.023 into 10 power 23 particles, that equal to exactly 22.4 liters of volume at STP. Based on all this data, we are going to find number of moles equal to given weight in grams by gram atomic weight or gram molecular weight. Right? Given weight in grams by gram atomic weight or gram molecular weight. Ila rayochu. Manaku weight iste number of moles kavalante formula given weight by gram atomic weight or given weight by gram molecular weight. Otherwise, the number of particles, ఎన్ని particles ఇచ్చాడో ఆ particles ని దేంతో మనం డివిజన్ చేయాలి? బై అవగాడ్రో నంబర్ 6 into 10 power 23 ఇలా చేయొచ్చు. అదర్వైజ్ volume at STP by we are going to division with, ఇది మిల్లీ లీటర్స్లో ఇచ్చాడు అనుకోండి 22,400తో డివిజన్ చేయాలి. If the volume at STP given in లీటర్స్లో ఇచ్చాడు అనుకోండి under STP conditions, you can division with 22.4. These are the different formulas for calculation of number of moles based on different data. మనకి ఇచ్చే డిఫరెంట్ డేటాను బేస్ చేసుకొని నెంబర్ ఆఫ్ మోల్స్ని మనం ఈజీగా క్యాలిక్యులేట్ చేయొచ్చు. ఓకేనా? రైట్. చిన్న క్వశ్చన్ రాయండి నాన్న. చిన్న క్వశ్చన్ రాయండి. Calculate, do this question. Calculate the amount of CO2. The amount of CO2 that can liberate 10.6 grams of Na2CO3 reacts with excess of HCl. Excess of HCl. ఈ ప్రాబ్లమ్స్ చేయాలంటే ఫస్ట్ we need to write a proper balanced equation. ఏం రాసుకోవాలి? ప్రాపర్ బ్యాలెన్స్డ్ ఈక్వేషన్ రాసుకోవాలి. What are reacting? Na2CO3 is reacting with HCl. ఏం రియాక్ట్ చేస్తున్నానా? ఆన్లైన్ స్టూడెంట్స్, we need to write proper balanced equation, that is Na2CO3 reacts with HCl. So Na2CO3 reacts with HCl can form what is that? NaCl plus H2O plus CO2. To get the stoichiometric calculations, we needed always a proper balanced equation. ఎప్పుడు కూడా ఏ ఈక్వేషన్ కావాలి? ప్రాపర్ బ్యాలెన్స్డ్ ఈక్వేషన్ కావాలి. Here how many moles of sodium atoms we have? 2 moles. So that you can write 2 NaCl. How many moles of chlorine atoms here? 2 moles. So that you can multiply with 2 HCl. So that the equation can be balanced. That means Na2CO3 can react with 2 HCl, can form 2 NaCl, H2O plus CO2. Now you can mark calculate the amount of CO2. He is asking the weight of CO2 he is asking. Okay, that can liberate 10.6 grams of Na2CO3. He is given that the weight of Na2CO3. Means the weight of Na2CO3 is given, the weight of CO2 we need to find. So first, as per the balanced equation, as we denoted already, if you write the formula of a compound, that indicates gram molecular weight. So how many grams of sodium carbonate we have? If you are going to calculate, you can get 106 grams, because sodium carbonate means we have 2 sodium atoms, 1 carbon atom, 3 oxygen atoms. So 2 sodium atoms means 2 into 23 plus 12 plus 3 into 16 we have. So if you add all these together, you can get 106. You need to express it in grams, because as we discussed already, what is that? The formula weight of any substance indicates that 1 mole. So we have 1 mole, so you can write 106 grams. So 106 grams of Na2CO3 on reacts with HCl can form how much amount of CO2? Here we are writing CO2 means molecular formula. If you are going to calculate that, you can get 44 grams. Right? Got it, Nana? So we know that. ఇక్కడ వరకు రాయండి, నెక్స్ట్ పేజ్లో రాద్దాం. So what do we know that? See, what do we know that? So we know that 106 grams of Na2CO3 can liberate 44 grams of CO2. But in the problem is given 10.6 grams of Na2CO3. This value we don't know. So on cross multiplication, 10.6 into 44 by 106, that you can get 4.4 grams of CO2. ఎలా చేయాలి? ఓకేనా? We are going to discuss the similar problems in our next class, and besides this we can discuss equivalent weight redox reactions, how to balance the redox reactions, what are the different concentration methods we have, and how the relations among them we have. We are going to discuss this kind of entire concepts in our next class. Thank you, Rana. Thank you, online students. Thank you everyone. Have a better time to you have. Good night, Nana. Bye.